Okay, so now we're out in the garage, and I've got some things laid out, and the reason they're already laid out is because this is like the 100th attempt at this thing. Okay, so what I've got is a piece of paper on a piece of plywood, and I put the paper out here so you could see better. Now I didn't show you this part. I measured the sink, and the sink is supposed to be, the hole for the sink needs to be 20 inches long and 17 inches wide. Now what I've marked out here is I've found the center. Here's where the center of my sink is going to be. And I'll get to these screws in just a second. They're part of it. Since the center is halfway between the two ends, my major axis is going to be 10 inches long. And my minor axis, since this distance is 17, my minor axis needs to be about 8.5 inches. I'm using the word about because this is actually going to be a construction job. It tends to go with the limitations of your tools, so we're only worried about getting close, not exact, although this will be pretty exact. Now, by definition, the ellipse, any point on an ellipse is equidistant. I shouldn't say equidistant, it's the sum of the distances from the two foci to any point on the ellipse, no matter what point I choose. The sum of these two distances always has to be the same. So the next thing I need to do is figure out the position of those foci, which I've already done here. We've got a 20 by 17 sink. My major axis is 10. My minor axis is 8.5. You'll notice the first time I did this I wasn't thinking and I just put 20 and 17 but crossed it out. And c squared in this case is equal to a squared minus b squared. Now, like I said earlier, in a news item, letters are just playthings to me, so if you get them backwards, you'll notice you've always got to, in this case, always have to be subtracting the smaller number from the larger number, and if you run into trouble, what happens if you reverse these, you end up with finding c squared, which would become a negative value, and then taking the square root becomes an impossibility. So anyway, using our numbers, we get c squared is equal to 10 squared minus 8.5 squared, which is 27.75, and the square root of that is 5.68. So again, using our construction about model, I'm going to round that off to 5 1/4, about a little bit more than 5 1/4, and that's where I placed these two screws from the center of the circle, a little bit more than 5 1/4 over. Then you need to take a piece of string, and I need to create a loop that's going to be the distance from here to here to here to back to here. Now the easiest way is to use one of the points on the major axis, because all I need to do is create a point or a loop of string that goes from here out to the major axis, back to this focus, and then back to this focus. Now, like the good cooking shows, I'm not going to take the time to show you that. I've already got one in the oven. Okay, so here's a loop that one end of the loop is on this focus, it passes as this focus and goes out to the end of the string. Looks a little big, but that's okay. We could, if we cut, which I'm not going to do at this point, I'm not going to bore you with cutting things. Oh, get my pen open here. And now if I take this pen and just use that as one end of the loop, and I'm going to try and hold my angle fairly close, but I'm going to keep the string tight. And this one looks like it's coming a little bit large. Whoops. I think my string is stretching. Back to where we started, but so there's approximately the ellipse I need to cut out of a countertop to drop in that elliptical sink. Now what I might do is cut this out and put it over the sink, the existing sink that's in there, just to show you that it actually does work, and the dimensions are probably more accurate than what I set out to do. But that's one practical application of conic sections that we're working on. And I actually have done, this is how I set elliptical sinks. Most of the time I find the templates that come with the sinks get lost or something. But so anyway, keep looking for applications. Where do you see either conic sections or trig functions or exponential logarithmic functions, whatever you see? What do you see out and about?